For this lesson, we are going to be identifying linear and exponential functions from a table. So let's see, what does a linear function look like? Notice I've underlined the word line. So a linear function will be a line. And when we're talking about a rate of change, we're always going to do rise over run. And that's what we're looking for, a constant. So we want a constant rate of change. And if you end up looking at this graph that you have, it says y is equal to 3x plus 1. We know that if we go up 3 and over 1, that will be our constant rate of change, rise over run. Well, exponential graphs look like this. This curved line is actually called an isotope, and it will not go ahead and touch the x-axis at all. So when we have an exponential function, remember I have underlined, or you can see I've underlined my x. And that tells me when I'm looking at the table, I am going to be able to see some multiplication happening. So for linear, we're either going to be adding or subtracting our values in the table. But for exponential, we're looking where is multiplication happening. And that x in there reminds me of multiplication. And so with so many words to remember, or with our language of math, I'm trying to give you some little helpful hints there. All right, well, let's look at our first question. And I see that I have a table. My x values are 1, 2, 3, 4. And as I'm looking at those x values, I do see from 1 to 2, it goes up 1. From 2 to 3, it increases by 1, and same thing here. So again, this increase has to be the same, but notice we're adding 1 here. So let's look at the y value. So it goes from a -2 to a 0 to a 2 to a 4. Well, -2 to 0, I know I'm adding 2. From 0 to 2, I'm adding 2. And from 2 to 4, I am adding 2. So I see I have a constant rate of change for my x and for my y. And if I was interested in the slope would be a 2 over 1. So as we're working these problems, let's go ahead and let's record just an L for our linear, and we'll write an E for our exponentials. All right, so seeing that there is a constant there, we know that this is actually going to be a linear function, which will, if we graphed it, would look like a line. All right, let's look at the next table. It doesn't matter whether tables go vertically or horizontally. We're just looking for what's happening to our values of x and what's happening to our values of y. So looking at this table, again, 0, 1, 2, 3. I see that it keeps increasing by 1. Let's look at our y values now. If I try to add from 2 to 4, I get a plus 2. But then if I go from 4 to 8, I get a plus 4. And from 8 to 16, I get a plus 8. Well, that is not a constant rate of change, so I know it is not going to be adding. So now let's see if it actually is exponential with multiplying. Well, notice 2 times 2 is equal to 4, and 4 times 2 is equal to 8, and 8 times 2 is equal to 16. So this graph definitely is going to be exponential. And I am just going to go ahead and I'm going to put my E there for exponential. Let's look at and that was number 2. Let's look at number 3. All right, again, I have a vertical table. I see my x's are increasing by ones. Okay. But now for my y's. 6 plus 6 is 12, and 12 plus 12 is 24. So it's not adding, it has to be multiplication. So I am multiplying both of these by 2. Oh, and the next one would be multiplying by 2. So I know that this is an exponential function. And it would, when graphed, it would look like this curved line. Looking at number 4, I see I have a -3, a 0, a 3, a 6, and a 9. Well, each one of these, I was adding 3 each time. So now let's look at the y's. I go from 10 to 1 to a -8, a -17, and a -26. Well, going from 10 to 1, I see I am subtracting 9. And from 1 to -8, I am subtracting 9. I'm decreasing. And I am decreasing by going down 9 for each one of these. And again, it doesn't have to just be adding. It can be decreasing or subtracting. So this definitely is a linear function. And looking for the last one. Here I have -1, 0, 1, 2, 3. Okay. And I'm looking at that and I'm seeing each one of those does increase by 1. Going on the bottom, if you have trouble dealing with decimals, we can just skip that and double check from 2500ths to 1 what that number might be. Well, let's look at 1, a 4, a 16, and a 24. Well, I know that 1 times 4 is 4. So I'm just going to write that down as an idea. And now I know 4 times 4 is 16. And 16 times 4 is 64. Well, let's go back to this one to double check. Well, 2500ths, think about money. 2500ths times 4 equals $1. So this graph also is what we would be considering exponential. Again, linear is going to be a line, and you're either going to be adding or subtracting, and it's going to be a constant rate of change. Exponential is where you're going to have multiplying, and you see that this is what our graph would look like for that exponential function. If this video was helpful to you today, please add a like, comment, and most importantly, subscribe for more Math with Marcia. See you again soon.